Okay, in this video we're going to be doing Calc Problem Set 41. The problems and a playlist are in the description, and let's do this. Evaluate. The limit is x approaches 3, x minus 3 over like the quantity, square root of x minus square root of 3. All right, so I can think of two ways to do this. One, the most direct way, I guess, is to just rationalize the denominator. So I'm going to do that. So I'm going to start with the original. I'm going to multiply the top and the bottom by square root of x plus square root of 3. The next step here is to expand, but you only want to expand the thing you're rationalizing. I'm rationalizing the denominator, so I want to expand that. I'm going to leave the numerator as it is, so just quantity x minus 3, quantity root x plus root 3, all over x minus 3. We cancel the x minus 3's, and then we substitute in 3, and we just get 2 root 3 is our answer. That's one way of doing it. A second way of doing it, which is probably the way that I would choose to do it if I had to do this problem, is I would factor the numerator. Like, it doesn't look factorable, but it definitely is factorable into square root of x plus 3 times square root of x minus 3. So I'm going to do it that way as well. And then you can cancel out the root x minus root 3's, and we are left with this, which gives us exactly the same answer, which, as we know, it better, because if you get a different answer doing it two different ways, one of those ways or both of those ways, probably wrong. All right, next question. Find the asymptotes of f of x equals the absolute value of x cubed over x cubed plus 27. All right, so horizontal asymptotes, you need a limit to infinity and negative infinity. And to really deal with this, we need to know about this absolute value of x cubed. But just think about it. If x is positive, x cubed is positive, and the absolute value is just whatever you got. So it's just x cubed. If x is negative, then x cubed is negative, and the absolute value will be the opposite of what you got. So we can rewrite the absolute value of x cubed as the opposite of x cubed when x is less than 0, and as just normal x cubed when x is greater than or equal to 0. This is going to be relevant because if you're going to infinity, then x is definitely positive, and you can replace the absolute value with just x cubed. If you're going to negative infinity, then x is negative, and you can replace the absolute value thing with the opposite of x cubed. So that's what we're basically going to do. So I'm going to start with this. I'm going to replace that absolute value of x cubed with just x cubed because we're going to infinity. Now I'm going to do the thing I usually do. I'm going to divide by the highest power of x in the denominator. So everything I see, x cubed over x cubed over x cubed, 27 over x cubed, which reduces down to 1 over 1 plus 27 over x cubed. Now if x goes to infinity, 27 divided by infinity is 0. We just get 1. And because we get 1, that means y equals 1 is a horizontal asymptote. Oh, this says asymptotes, not just horizontal asymptotes. I should have also done vertical, which I did not do. X equals negative 3 is a vertical asymptote. I'll write it in at the end. Let's go to negative infinity now. So for negative infinity, the absolute value of x cubed is replaced with negative x cubed, giving us this. And then we divide through by the highest power of x in the denominator, giving us negative 1 over 1 plus 27 over x cubed. If x goes to negative infinity, 27 divided by infinity is still 0. So we are left with only negative 1. So y equals negative 1. And now I have to handwrite this in on the fly. And as you may know, I hate that. But we also know that there's a vertical asymptote. So x cubed plus 27 equals 0. X is negative 3. So that's a vertical asymptote as well. All right, so we'll add that one in, and let's take a look at the next problem. So always make sure you answer the question. Obviously, I don't always answer the question. We want to find a and b that make the function shown below differentiable. All right, so I'm going to do kind of bad work on this because I don't want to take the time to do perfect work where I'm writing limits and things like that. Also, I feel like a lot of people get lost in the process there, and they don't realize these are pretty simple problems to answer. It's the notation that's hard. So the first thing you do is you just take 3 and you plug it into both branches. That's going to force this function to be continuous and set them equal. So I'm going to plug 3 into the top branch, which gives me 9a minus 9, 3 into the bottom, which gives me 27b. I'm going to rearrange this so that I can use it in a system to solve. So I'm going to say a minus 3b is equal to 1. Now for differentiable, I'm just going to take the derivative of both branches. So the first one, it'll be a times 2x, so 2ax minus 3. And then for the second branch, the derivative of bx cubed is 3bx squared. So I'm taking the derivative of both. And that'll make this thing differentiable. So here goes. We got 2ax minus 3 equals 3bx squared. I'm then going to evaluate that whole thing at 3, which gives me 6a minus 3 equals 27b. I'm going to rearrange this so I can use it in a system. So I divided by 3 because it just like makes life easier. All right, so this, now I just need to solve the system. So let's set up the system. So we have this. I'm going to multiply the top by 2, and then I'll do the thing I usually do, just subtract the bottom from the top. So I'm multiplying this by 2. So I have 2a minus 2a gone, negative 6b minus negative 9b is 3b, and then I have 2 minus 1. So I have 3b equals 1. And that means that b is 1/3. And then if you go to a, basically a is equal to 1 plus 3b from the green continuous part. So we end up with a is equal to 2. All right, let's take a look at another problem. Given f prime, so make sure you notice that that's f prime and not f, so you don't want to like find an extra derivative that you don't need. F prime is the quantity 3x plus 1 to the 4th, the quantity 2x minus 7 to the 7th. Determine where f is decreasing and concave down. So decreasing means f prime is negative, concave down means f double prime is negative. We're looking for them both to be negative. We got to find this derivative. This is a product rule. It's a product rule we've done a bunch just in the problem sets and definitely in class and things like that. So first derivative second plus second derivative first. Don't forget the chain rule. Factor this thing. Gives us this. Clean up that last set of parentheses. Gives us this. I know that you can do this, so I'm not making you watch me do it, but like it is tricky. You have to keep track of a lot of things, but I don't think me talking through it is necessarily going to help. So you can just check your work against it. Now I'm going to make some sign charts. So for f prime, the only zeros that I have are negative 1/3 and 7/2. Plug in negative a billion, something to the 4th is positive, and then you get a negative to an odd. So we're going to go negatives there. Negative 1/3 comes from an even degree factor, right? The multiplicity is 4, so that's even. So there's not going to be a sign change, so we're still going to be negative. 7/2 comes from something to the 7th, which is odd, so there will be a sign change. Or just test. It doesn't really matter. We got to do the same thing for f double prime. So f double prime, negative 1/3 and 7/2 show up again, but also 35/33, which is a super annoying value, but whatever. It's definitely between them, so that's all that really matters. Plug in a negative, and you get 2 times a negative times a positive times a negative. So there's 2 negatives overall, so we are positive. And then negative 1/3 comes from a 3rd degree thing, so there will be a sign change. 35/33 comes from a 1st degree thing, so there will be a sign change. And 7/2 comes from a thing to the 6th, which is even, so there will not be a sign change, so we're positive there. We were looking for decreasing and concave down, which means both had to be negative. So if you just look, I mean, there's your interval where they're both negative. That's why we make our sign charts the way we do, where we space them out, put lots of pluses, lots of minuses, so you can just see what's happening. So I'm going to write up my answer. F of x is decreasing, concave down, on negative 1/3 to 35/33, because f prime is less than 0, f double prime is less than 0 there. That's our answer. That's the whole problem set. I hope you found this helpful, and good luck.